Hi, my name is Faro Najrabi, and this is my presentation on using Spyder Integrated Development Environment to perform a telehealth audit. Health insurance companies rushed to incorporate more telemedicine policies within their companies in the onset of the COVID-19 pandemic in the beginning of 2020. The companies seemed to update their guidelines weekly to keep up with the worldwide situation. Normal procedures of collecting copays, deductibles, and other out-of-pocket costs were impacted by more Americans losing their jobs. Among all the chaos, providers began noticing a surge in claim denials. The denials resulted from incorrect submission of claims to the payers. Patients also started to notice a trend in faulty bills. They were being billed for things that they shouldn't really need to pay. And this happened because providers were submitting claims to the health insurance companies and they weren't submitting it correctly, so they were obviously not being paid correctly, and therefore it was being assigned to the patient as the responsible party to pay. This topic is important because there are numerous points at stake. The provider can experience a loss of revenue and could also experience an unauthorized gain of revenue. More importantly, the practice can become subject to a serious external audit, and the results of the audit could lead to terminations of contracts with payers. All of this could lead to the client pool to decrease and ultimately end up with the closing of the business. A prime solution for such an issue would be to hire or train a staff member to audit the details of claims that were submitted to payers. All claims with dates of service of March 1st, 2020 and later will be analyzed. March 1st, 2020 was the beginning of the COVID-19 pandemic. The auditor will use the program which was created in Spyder with Python programming language to vet through the data and produce a set of results that contain the incorrectly submitted claims. Incorrectly submitted claims will be the ones that do not contain the telehealth modifier, so like 95 or GT, and who also contain the incorrect place of service on the claim. The place of service for telehealth visits should be a 2. For office visits, it's an 11, so it should always be a 2. Once the incorrectly submitted claims are retrieved, the list must be sent to billing department team members so they can correct and resubmit them. The use case diagram here shows a visual of the possible interactions that the user may have with the system. So here, the auditor can have 4 different interactions with the system, and you can also see that 2 of the interactions can result in another set of interactions that don't always have to happen, but they could happen. So it means that when the auditor, for example, executes the code, it could be that the data source not found error could occur, but it doesn't always have to occur. It just depends on if the other parts of your code are correct or not. As stated, we will use the Python programming language to complete the audit. Before running this program, we need to have our data that we will be importing into the program to analyze. This data will come from the EMR. Unfortunately, our program cannot have direct access to the data inside the EMR, so we need to use an additional tool. This additional tool is provided by the practice, and it's not really the topic of our presentation, but getting that data is important for us to be able to perform our program. Once the data from the EMR is obtained, it needs to be saved in CSV format onto the C drive of the computer. As we begin, we need to make sure that the Pandas module is imported into the Spyder interface. This module is essential to be able to perform our analysis on the data. The code will start with a statement which will finally import the data from the EMR, but again, not directly from the EMR, it's from our worksheet. Throughout the code, different statements will be utilized to narrow down the claims that we are only concerned with. Here we have the first section of our code. As you can see in the beginning, I imported the Pandas module and that's important again because we need it to analyze our data. Right below, I've named a data frame DF, which is the section that imports our data set that's saved onto the computer as the CSV file. And below that, we have a bunch of different statements. All of them are labeled, and they basically take you through the steps of how I analyze the data, step by step. Every time you see an equals, that's a new data frame. Each data frame is like the filtered set, so it's step by step. You'll see what I mean later. Here we have the second section of our code. It starts with line 56. The last one ended with line 55. I want to highlight here what we're looking for. Right here, it's looking to see if the claim has a modifier 95 or a modifier GT on it. If it does, it will return a true. If it doesn't, it will return a false. It does the same thing down here with the place of service. So if the place of service is 2, it will include true. If the place of service is 11, for example, then it will include false. I say 11 because remember 11 is the in-office place of service. Now in the end, a new column will be created to check if both of these resulted in true. If so, it will remove those claims because that means they had a modifier, a correct modifier, and the correct place of service. So it doesn't need to be on the final data set. Now, if either of these is false, it will remain on the data set. Now, it doesn't matter which one is true, which one is false. It's just if one of them is false, it will remain because there's some sort of error. Once we run our code, we see some activity in the variable explorer. Those are all of our data frames that we had created within the code. They can be considered as all of the steps we took to narrow down our data set. The ones labeled with final, those are our final results. I had to split them up by pair because that is how I'll be distributing them among the different department members. Each member is responsible for a particular pair. Finally, we can view one of our result sets. You can see the 3 additional check columns that we had placed into the report. For example, for index 702, the first line, the claim line failed the modifier check but passed the POS check. It's included in this report because there's at least one aspect that is incorrect. There are many ways that the program can improve. One way would be to have the distribution of the final results become automatic, so a way that the report can save automatically onto your computer. It can get a bit tedious copying the data set from Python. It's not as easy as you would think. Another way is to have an aspect that only includes new claims. We can use this to see the rate of errors that are happening currently. We can also implement another improvement that will check if the CPT code matches the communication method indicated in the clinical notes. For example, if the clinical notes indicate a video visit and the CPT code is either 99441, 99442, or 99443, which are audio codes, we can be sure that the bill is incorrect. Believe it or not, this is a common error. The COVID-19 pandemic motivated providers all over the country to utilize telemedicine more. Insurance companies were also rushed to make decisions on what they would cover as it related to insurance plan benefits. The fast-paced change that was undertaken resulted in some missing pieces. Nevertheless, insurance companies and the government take medical billing very seriously. Claims should be submitted correctly at all costs. The newly created Telehealth Audit program assists providers to ensure their billing staff is billing payers appropriately. And that concludes the presentation. Thank you for watching.